become a member today. All right, well, welcome everyone to the basics of rainwater harvesting for residential use. This course is approved for 1 hour in continuing education units, including the lead AP professional, as well as always AIA health, welfare, and safety, which may make it applicable to your state-based design or contractor license. Today, I will be your moderator. My name again is Brett Little here at the nonprofit, the GreenHome Institute. We're going to be taking a look at rainwater harvesting processes, water quality applications, and the common myths surrounding rainwater. And before we get started, a huge thanks to our top tier sponsor, introducing the all-new Rheem Prestige, an energy efficient, quiet, and all-electric hybrid heat pump water heater. The future of water heating is finally here. 50, 65, 80 gallons. The Rheem Prestige can serve many of your different clients' different needs, all the way up to 300%, nearly 400% energy efficiency with a 3.7 uniform energy factor. 10-year warranty, quieter than the typical loud heat pump, and rebates are available. One thing we're really excited about is the 2 different ways you can vent this system, depending on your needs, your basement strategy, where you're locating it, and what climate you're in. You can talk to your HVAC contractor and your home energy assessor on best how to do that with your client. The Rheem Prestige also helps your clients stay smart with service notifications, potential leak detections, but you still want to get that drip pan installed. And one cool thing they're doing now with utilities is they're using these water heaters as battery systems. So you can check that out at a local utility near you that is progressive enough to be working on a program like that. Learn more at rheem.com/hybrid savings. And then also thanks to our sponsor, Niagara Conservation. Niagara, it's no surprise that toilets are the #1 cause of high water bills, and yet savings are only a simple flush away. Niagara Conservation has answered the call by developing the world's #1 water-saving toilet using vacuum-assisted technology. And that's right, vacuum, not pressure-assisted. We have glowing reviews from multifamily affordable housing renovation specialists who only spec these toilets because of their durability and cost savings. If they work in that situation, they'll work anywhere. ADA side handle also available. So how low can you go? There's the 0.8 gallons per flush on the Stealth single flush, getting rid of those confusing dual flushes. They also have the Nano that goes all the way down to 0.5 on a dual flush side. And then you can also check out some of their other products from AM, 1.25 on the shower head, very low, very comfortable, 0.5 on the aerators, super low, don't even notice it. All of them are WaterSense certified. Check it out over at Niagara Conservation. So I wanted to introduce our session speaker today and then hand it off to him, Daniel Roche. He's been in the water quality industry for 7 years as a 2nd-generation water quality specialist. Daniel is highly motivated and passionate about rainwater harvesting. He loves to share his passion with others through good conversation and education. And so with that, I will hand it off to you, Daniel. Please go ahead and take it away.
Awesome. Thank you, Brett. And thank you, everyone, for tuning in. Let me get this pulled up here. Okay, yeah, as Brett said, I'm Daniel Roche. I'm with a company called Perfect Water. We're in Knoxville, Tennessee, is home base, and we work really all around the Southeast. He mentioned I'm 2nd generation in the water business. So my dad started Perfect Water in '97, and we started, our background as a company is water purification and filtration. And really in 2010, we started learning about rainwater harvesting systems and put in our first systems then. And so we're a decade in now of doing rainwater harvesting for residential, which is what I'm going to talk about today, and also commercial and industrial properties. So the way we look at rainwater harvesting as it can be used for homes comes from that backdrop of wanting to achieve a very high quality of water. So the basics of rainwater harvesting, I'm going to talk about different applications that rainwater harvesting systems can come into play for residential use, and benefits that they can bring homeowners and contractors. I'm going to try to hit some of the, as Brett said, some of the myths around rainwater harvesting in the United States, and show a series of case studies, jobs that we've done and how they were applied in the home and what goal they were looking to achieve. And at the end, I'll have questions, so I expect there may be a few. Active and passive rainwater harvesting systems. Passive being rain gardens, really more features in the landscaping to collect and allow the rainwater to be assimilated in a responsible way. And active being a system that actually collects and stores the water and can be actively used for an end purpose. And so active is what we'll be going over today. That's what our company specializes in, and all of these components and processes I'm going to talk about are for active rainwater harvesting. The definition that we use for rainwater harvesting and what we'll be talking about is the capture and storage of rooftop rainwater for retention for future use and or detention for stormwater runoff compliance. Rainwater harvesting is not reclaimed water. It's not reuse water, not recycled. It's not gray water. It's a misconception to think that you're starting with a lower quality of water than any other water source that we use as a society, because in reality, it just fell out of nature's big distiller, which is the clouds. You know, the water cycle begins with evaporation into the clouds. At that point, it's not bringing any bacterial content, no inorganic or organic impurities. So you're starting with a very high quality of purity in the clouds. And what I'm going to be working through it in terms of how a successful system works is we're really just trying to maintain that high quality of water that it began with in the clouds. We want to carry that on through whatever end use there is. So uses for rainwater harvesting, potable and general use water. A lot of families around the world, but more and more now in the United States, are using harvested rainwater as either their primary water source in the home or their sole water source in the home. We work with a lot of clients and know of a lot of stories of people who have no other water source on their property, and they've been living now for a decade, enjoying a really high quality of water for drinking and general use. Irrigation is kind of an obvious one. A lot of people, when they first think of rainwater harvesting, that's often where their mind goes, and it can certainly be used there, especially in the right applications. It can be really helpful. Gardening water, I kind of make the distinction there, where you might be looking at a little less capacity than a typical irrigation system. It might be used just around the house and gardening purposes, but a non-potable use would be the difference between general use water and gardening. Stormwater control. Most people do not, I find, consider rainwater harvesting when they think of controlling site water runoff or stormwater control, but it really has a lot of benefits in that world. And I'm going to show you a case study or two on that and how that can be used on a project. Emergency water. Finding a lot of people just really like the idea of having an independent water source, and so certainly rainwater harvesting can be used for that. And then fire protection, very similar to emergency water, but especially in commercial properties, or if you're in a part of a country with a very rural environment where it may be difficult to get stored water out quickly, rainwater harvesting systems can touch that world as well. So benefits. Stewardship of the environment is a big one. Groundwater resources are not an infinite supply of fresh water. There are places throughout the country where groundwater levels have already been depleted so much. And we run into it all the time as a company, just because people who have dry wells call us. And so I think I see so many of the areas now that have for years had great groundwater supplies that have dried up. And so being able to capture the rainwater as it falls on our own properties, instead of diverting it off and sending it to the nearest creek and stream and down to nearest ocean, it's very responsible to capture and save. Reducing the carbon footprint of centralized water systems. So we're all used to large utility companies being able to send out water to their districts, and all of the associated manpower and equipment and infrastructure that goes along with centralized water. And then controlling runoff from hard surfaces. So preventing massive inflows into creeks and streams and disturbance of wildlife there. We've been able to work on a lot of those projects and seen a lot of those projects in rainwater harvesting. Superior water quality is a benefit of rainwater harvesting. As I mentioned earlier, it's a very high quality of water, and so people enjoy using it in the home because of the water quality, not despite the water quality. Availability of water, again, hits on the either reduced groundwater resources or areas where other water sources are unavailable. Rainwater harvesting can come in and in a lot of regions of the country be a great sole water source. Stormwater control, I've hit on that already a little bit. Lead points, others would be able to speak more educated than I on exactly how it fits into like a lead build, but I know there are points to be had in rainwater harvesting. And then an independent water source and future ROI. So, you know, a lot of people look at current water rates, and it's obvious that over time those rates will go up, and as infrastructures are updated, and so people are investing in rainwater harvesting systems for their homes for protection against any increases in the future. So here's a lot of the meat of what I want to talk about, and this is the process of rainwater harvesting for American homes, where we want to be able to keep a high quality of water. We want it to be efficient, sustainable, low maintenance. And this methodology that we use, it's a 5-step system. It was developed in Germany, where there's a lot of rainwater harvesting industry. And the key features of this process, this method of rainwater harvesting, is it's very low maintenance. It maintains that high water quality, and it's totally scalable from, again, homes to resident or commercial and industrial applications. So you can see here there's the 5 primary steps, and then 6, 7, and 8 are additional options that can be added to achieve different things. But capture and conveyance, pre-filtration, the storage ecosystem, storage, and then pumping / filtration purification. Those are what I want to get into right now. So capture and convey, this is the rooftop being the capture surface. This is not coming off of driveways or other hard surfaces. We're talking strictly rooftop capture. And the conveyance component brings the water from the downspouts and gutters towards the storage system. So this is the first step. You've got to capture the water on the roof, get it brought together towards wherever the storage is going to be. Here's some examples of a conveyance system. So on the picture on your left with the green pipe going down through there, that's a 4-inch conveyance pipe that is going up and connecting to these downspouts on this home. So the water has been captured on the roof, it goes down the downspouts as normal, enters this conveyance system, and then will eventually circle back down towards the storage tanks. In this picture on the right, this is also a conveyance system just suspended underneath the deck. So all of the downspouts were collected, And in this situation, storage tanks were back in a storage room under the home, and conveyance was simply mounting it to the bottom of the deck. So important considerations on conveyance systems is certainly sizing. You want to make sure you can handle the flow rate from a given roof. Material, being, especially in a potable application, conveyance pipes that won't leach, and you don't want corrugated conveyance pipes where they're, one, easily broken, and two, can build up a lot of organic matter down inside of those ridges. And you also want to make sure it's sturdy enough if it's going to be in a traffic area with vehicles driving over and whatnot. And then type, so wet or dry conveyance. And these next two slides are going to try to show what that means. So the dry conveyance system is, in this case, this big gray box would be the structure, and then we'd have the gutter and downspout coming down the side into the conveyance pipe, just like those pictures I showed you. Goes into the conveyance pipe and drains down into the tank. And so this brighter blue on the bottom of this tank diagram would be the water level, and you can see the conveyance pipe does not have any water in it. It's dry. It only has water flowing through it when the system is experiencing a rain event and water's flowing down towards the storage tank. A wet conveyance system would be when you do not have the ability to either sink a storage tank or have an elevation drop, if the tank's right next to the structure. And you can see here, this would be similar to like a P-trap under a sink. The water level would go up the conveyance pipe, which would be going vertically up the building, and then force its way into the tank. So each time it rains, it forces it in from the downspout side near the house and into the storage tank. So we've done jobs personally as a company where that vertical section of the wet conveyance pipe is over 30 feet, and it forces it down underground just like a P-trap, and then over into the storage tank. Second step in the 5 steps is very critical. It's pre-filtration. So this is pre-storage filtration. When the conveyance pipes run together, before they enter the storage tank, it goes through a pre-filtration device, and it is to divert rooftop debris. So leaves, twigs, grit from shingles, whatever it is, it gets diverted and unable to enter the tank. The other thing the pre-filter does is it oxygenates the water just by the way it's cut before going into the storage tank. And in step 3 of this system, you'll understand why that's important, that it be oxygenated. Key features for pre-filtration devices, and there's plenty of them out in the market, but it needs to be able to discharge the debris. So it's not just holding on to everything it captures, where it then has to go and be cleaned out frequently. It should be able to divert leaves off to normal stormwater runoff and clean water going to the tank. High efficiency of water to storage, so you don't want to be losing a lot of the water you want in storage going down to the debris discharge. Pre-filter should be resistant to plugging. Essentially, if you're in a part of the country where pollen season can be pretty intense, here in Knoxville, Tennessee, that is the case. And so if your pre-filter is too fine, it can be plugged up fairly easily with pollen. And it should be a sealed pre-filter. You don't want any gaps where bugs or mosquitoes or rodents could get around the filter and into the conveyance system, into the tank. You want that pre-filter to ensure if anything got in the downspouts, in the gutters, and into the conveyance system, that it would not be able to make it into the tank. It would always be diverted towards discharge. The storage ecosystem. This is really the magic of a successful rainwater harvesting system. When I say successful, I mean a system where the water in storage, no matter what the volume is always slime-free, color-free, and odor-free. Because if you can, again, maintain that high quality of water in storage, then when you pump it out for use at whatever your application is, it takes very little by way of filtration to make it potable or ready for irrigation, whatever it is. So the ecosystem is a healthy deck of bacteria on the bottom of the storage tank. It grows naturally just by the water coming in, oxygenated from the pre-filter and free of a lot of the heavy debris. And then, you know, it sounds so counterintuitive, but things like bird droppings on the roof and whatnot will feed into that biofilm that grows on the bottom of the storage system. And once it's in place, it eliminates the need for adding any kind of disinfectants to the storage tank to keep the water from getting stagnant or odorous or slimy. And it's very critical for a successful system. Otherwise, you're dealing with yellow, smelly water coming out of storage, and it takes a lot of work to get that pulled back out once it's present in water. So 3 areas that need to always be looked at in terms of storage is storage system volume, obviously. And if it's going to be a single tank or a balanced tank, basically meaning balanced is, another word would be daisy chained tanks, multiple tanks together operating as one. There's a lot of different storage types, most common being polyethylene, but you can see there's steel, fiberglass, bladder tanks, and timber, and I'll show pictures of all of these types here in a moment. And then the storage type, storage system installation. So they can be below ground tanks, above ground tanks, partially buried, and then certainly tanks could be indoor or outdoor. And those are kind of the decisions that need to be made when considering storage. Here's a picture of 2 below ground polyethylene tank installations. So you can see obviously these are before backfill, but these would be backfilled with gravel and then fill dirt to bring it up to grade. Here on the picture on the left, you can see back in the left corner of the tanks, there's this black device. That is a pre-filter. So in this case, the conveyance would be coming down the hill from the left side, enter the pre-filter. Debris would continue down the hill, and then clean water would go into the tanks. Here are above ground steel bolted applications. So the system on the left is an example of a balanced tank system. All 3 of those are connected on the bottom with crossover pipes. And so when the water enters tank 1, which is the one nearest the structure, all 3 of the tanks fill up simultaneously. And the one on the right would be obviously a single tank storage system. And you can see there's a variety of different looks you can go with. Both of these are kind of a conical top. One has ridges, one doesn't, but they come in flat and they come without the corrugated steel sidewall. It's really just whatever a homeowner or a client would be looking for. Here's partially buried polyethylene. So again, this is before backfill, but it shows the crossover hose, which is the white hose along the bottom of the tanks that allow those tanks to fill simultaneously. And then dirt will be brought up to about 18, 20 inches up the side of these tanks. And so that'll allow here on the bottom right of the picture where this water line comes out, that'll allow the water line, which will eventually be the pumped pressurized water back to the home, to be in our part of the country, which is again the southeast below frost line, but you know, depending on where in the country, however far down that would need to be to achieve freeze protection. Above ground timber, wooden sidewalls, and then again, there's various roof structures available just depending on a particular look people are trying to achieve. Usually these timbers would be also lined internally with a polyethylene liner, and but there are also true timber tanks, obviously, especially, you know, New York City, different places have a lot of timber tanks, and they're available for rainwater harvesting also. And people get creative with storage. We've had multiple clients do murals on the side of the tanks, and so I just like to show this picture to say it can be worked in as a design feature in a home. The actual storage tank, if it is an above ground tank that you're going to be seeing. So determining the volume of the storage system is you want it to be the balance between your yield, which is how many gallons are going to come off my roof, and I'll talk about that here in a few slides, versus your demand, and that's more of an estimate. So if it's for a home, we try to figure out, well, how many gallons per month is this household going to use, either through estimating by number of people in the home or looking at past water bills, whatever it is. If it's for an irrigation system, same thing, how many zones, how many cycles. And then you size the storage to be the most efficient there. It's not always the best to have maximum amount of storage, because in a lot of cases you'd be paying for additional storage that would never get filled up. But you also don't want too little storage that it's overflowing and you're using it up too quickly. If you're using the system for stormwater control, storage is very important to make sure that you can capture a certain volume of rainwater off of a hard surface and deal with it either through leaching it back out of the tank slowly or going to an irrigation system, such that there's always sufficient volume for the next rain event. That brings us to step 5. So the 5-step methodology here would be pump / filtration purification, depending on the use. So pumps can be submersible pumps inside the tanks or external, using a flooded suction to the pump, and they get pressurized and pumps get sized just depending on what the usage demand is. And filtration and purification. So this is, again, going back to Perfect Water's roots, and certainly my professional roots being water filtration. And to turn this rainwater that has been sitting in the storage tank with the biofilm, the healthy bacteria on the bottom of the tanks, the only steps it needs to go through to be comparable to purified water is a 5 micron sediment filter for any floaties that may come out of the tank, activated carbon, and so this would deal with any organic impurities the rain may have picked up fallen through the sky, and ultraviolet disinfection. So that's the most critical to deal with microbiological problems from water and storage. Excuse me. So to recap the 5 steps, it is capture and convey. We've got to bring the water together, head it in the direction of the storage system. Pre-filtration, the storage ecosystem, the biofilm, the magic of rainwater harvesting. 4th, the storage, and then 5th, the pump and filtration / purification. So for calculating yield, if you want to know how many gallons you can expect off of a given roof, quick number would be off 1,000 square foot of roof, approximately 600 gallons will be yielded per 1 inch of rain. And there's some variances there, but that's just a quick number you can pull off the top of your head. 1,000 square feet, 600 gallons. The equation is you take the roof footprint. This does not factor in any kind of pitch. That doesn't matter. You're just strictly looking for what's my footprint of roof. Multiply that by 0.623, and that'll equate to the subtotal gallons per inch of rain. And then you apply a loss coefficient. So, different roofs have different loss coefficients. A tin roof or a slate roof has a very low loss coefficient. Most of the water that's going to land on that roof is going to make its way down to the down gutters and then eventually the storage system. Cedar shake roofs, different shingle roofs will have a higher loss coefficient that gets plugged in. And so that's the equation. Footprint times 0.623, that'll be your gallons per inch of rain, and then add a loss coefficient to that. And you can calculate any area for how many gallons are going to fall per inch. Roofing material and gutters. So metal, slate, membrane, and most asphalt shingles are okay for potable use. There are certain asphalt shingles which should not be used in potable applications, where the shingles are impregnated with formaldehyde for algae resistance. Those are rare, but they do still make them. And we really were a guinea pig company in finding that out for the industry, is that these certain shingles that have formaldehyde, it will wreck that biofilm, that healthy layer of bacteria, the ecosystem, won't allow that to grow, and then your water quality is tanked, and it's very, very difficult to get that filtered back to a condition that you can use it. And so that's an important consideration when you're looking at roof materials. Most asphalt shingles work great though. If we take a full 75 parameter water quality analysis post-installation coming off of an asphalt roof, you can see that the water quality has maintained a very high level. Gutters and downspouts, it's a common question people have in rainwater harvesting is, what do I have to do? Is it different? Your gutters and downspouts should go in as normal. However, in the case of a wet conveyance system, obviously, there are cases when the downspout itself is replaced by a conveyance pipe, which can be painted, made just to look like a round downspout. But in a dry conveyance system, looking externally at the house, you can tell no difference. The conveyance system picks it up at the bottom of the downspouts, and your gutters and downspouts look the exact same. Backup and crossover. Many homes, if they are using rainwater as a primary source but still have a backup source, will have a crossover function between the two. And often it's automated, meaning rainwater tank gets low, a float switch is tripped, and a motorized valve turns, which seamlessly switches the home back over to the other water source. And then when rainwater is restored, it seamlessly switches back, defaults to rainwater. Of course, it can also be manual valves, but there's usually a crossover. The crossover takes place usually at the filtration panel. It is not a case where if your rainwater tank gets low, then you refill it with your other water source, such as municipal water, well water, whatever it is, because you don't want a foreign water chemistry to enter your storage tank, because again, you risk damaging the biofilm. If it's a crossover to a municipal source, then there certainly needs to be the appropriate backflow prevention for whatever local codes are. And then an emergency fill port would be, if it is a sole source situation, the emergency backup would be you are forced to bring water in and put it into the storage tank. In those cases, it's just a matter of talking with the professional and making sure that the water quality that you're putting into the tank will be acceptable. If it's a municipal water source, make sure that it runs through carbon to pull the chlorine back out, so that it's not, again, wrecking that biofilm on the bottom of the tank. A capacity regulator, one of the case studies I'm going to show here in a moment, uses a capacity regulator. It's used for stormwater control. So essentially, if you have a 5,000 gallon storage tank, and to achieve stormwater compliance, you need to be able to capture the first 3,000 gallons of water that's going to come off of a roof. A capacity regulator would slowly drain the tanks over a period of time, depending again on local stormwater regulations, so that, say, every 2 days after a rain event, there is sufficient available volume in the storage tank to capture that next 3,000 gallons that comes off of the roof. So I'll go into that a little bit more on the case study. Off-grid solar power integration. I just like to make these points in terms of a rainwater harvesting system that while off-grid solar I realize is less common, we've certainly worked with plenty of clients who use it. And when you're using a rainwater harvesting system, it's easier to pump the water from a storage tank that's roughly the same elevation as the home or whatever application it's going to be used in, rather than a well where you're going down several hundred feet or whatnot. It just limits the size of pump you need, and so you're able to get by with less electrical demands on those pumps. And then you can also very easily install hand pump emergency backups for an off-grid solar integration. Laws and regulations. I would say this is the #1 question or comment I receive and that I read online that people have on rainwater harvesting systems. There's a perception that it is illegal in the United States, and the reality is almost every state has no regulations at all on rainwater harvesting. Several states promote rainwater harvesting with tax breaks and just red carpet from local codes offices, because they love that it is helping with stormwater control and that it is beneficial to the environment. Colorado and Utah are the 2 states in the country that have the most restrictive laws. Outside of those 2 states, you can, without worry of breaking the law, utilize rainwater harvesting. And codes, building codes for rainwater harvestings are in the works. The last industry trade show, there was a big presentation on codes in ICC and IAPMO coming out for rainwater harvesting systems. And so it is becoming more mainstream, I guess, in the building world, and there's going to be codes for it. If there are specific local codes offices or inspectors that want to look into it a little bit more if a rainwater harvesting system is integrated at a home build, we as a company have had no trouble getting this 5-step method approved. Here's just an example of a home where you can see there's stamped drawing showing that exact same method that I just described to you, those 5 steps for use in new construction. This was in Knox County, which has pretty active codes and regulations. And we've done this in multiple states, various counties, and never run into any trouble as a company. This is actually that job. So this drawing became this job. You can see it was integrated during the home build. This very far left picture, you can see the conveyance system start and go underneath the driveway. All of these are stub outs on the second picture for downspouts. And then the storage tank. So this is a 5,000 gallon storage system. The roof footprint of this home was 3,800 square feet. And this became the primary water source for this residence. They did have a city water backup that if the rainwater tanks ever do get low, or if there's a pump failure, whatever it is, it'll automatically seamlessly switch them over to municipal water. This is another family that integrated their rainwater right at the home build, and they decided they were not going to look for any other water source. And so for almost 10 years now, harvested rainwater has been their only water source for their home and property. Again, 5,000 gallons, below ground storage. By the time this is all done, you can see 1 manway cap from the primary tank, and they just live like Americans and have great water. This is a home where you can see here 7,000 gallons of below ground storage. The middle picture there is what it looked like by the time it all got backfilled, just the 1 single manway cap from the primary tank. And this was a flat roof membrane came down internal downspouts in the home, and then out towards storage. That was a dry conveyance system. I should note here too, I've referred to primary tank several times, and I realize I kind of went quickly over the section of the storage, but in the storage tank, in order to allow that ecosystem, the biofilm on the bottom of the tank, to grow, there's several components inside of storage that work together. So you've got the pre-filter that oxygenates and filters it down to a certain level. But inside of the tank, you've got to have a calming inlet that prevents the water from disturbing the bottom of the tank. You've got to have an overflow device that allows the tanks to overflow without letting bugs and mosquitoes come back into the tank. And then the pump has to be able to draw with a floating intake so that it's not sucking the water from the bottom of the tank. And then other things like capacity regulators would also go into that primary tank. So when I say primary tank, it has all of those various components in it. And then the additional tanks in this picture, 2, 3, and 4, have no internal components. They are just simply balanced to that primary tank with a manifold on the bottom. And so that's why only one of these manways was exposed in this situation, because to access any of those internal components, just need access to the primary tank. Here's another sole water source. So this is an example of partially buried polyethylene tanks along the back side of this home. And you can see on the far left picture, this device mounted to this post is a pre-filter. So water is coming in. This was wet conveyance because it's coming up the vertical and into the top of the pre-filter. So water is in that column of pipe, goes through the pre-filter, then into the storage tank, and both tanks are chained together to operate as one. This lady again, she was over in Nashville, Tennessee, building a home, decided not to drill a well, decided not to hook up to municipal water, and has been living entirely on harvested rainwater. This home is using harvested rainwater strictly for irrigation. It's a drip irrigation system and 7,000 gallons of below ground storage, submersible pump inside of the primary tank. Again, you can see the pre-filter over there on the far left corner of the tanks. It's being pumped out of there and then connecting to the irrigation system. It does have an automated backup, so when the tanks get low, kicks them right over to the next water source. Here's a job where the rainwater system was primarily installed for a unique stormwater runoff control. So this home, all of its runoff, which is a very large rooftop, you can't see it all in this picture, but between a freestanding garage and the home, the problem they were running into was all of the runoff was going down into a stream, which was over on the right-hand side in the woods on the right-hand picture. You can't see it, but it's down there. And that stream was going across the road and completely washing out the neighbor's driveway and causing flooding. And so they needed a way to deal with all of that runoff without disturbing the wildlife in the creek and without damaging the neighbor's property. And so in this case, all of the water enters a 7,000 gallon below ground storage system. You can see in this picture on the right hand side, this blue container, that is a pre-filter. And then the manway right next to it will be accessible when everything is backfilled. And then tanks 2, 3, and 4 are going to be completely underground. This system is set up to slowly drain at about 1.5 gallons per minute the water from the bottom of the tanks down into that creek, so that after a rain event and that storage system gets filled up to however much rain fell, it immediately starts slowly draining the stored water into the creek at a rate that's not going to cause any washout or flooding problems. And it's going to drain 24/7, and the goal is over several days that that tank drains enough to ensure that 7,000 gallons is ready for the next large rain event. And so there's an application and of stormwater control. This system is also hooked into irrigation. So during the summer when the irrigation system is running, in addition to having the 1.5 gallon discharge into the creek, whenever the irrigation system kicks on, it pulls those tanks and aids in getting those drained out and ready to capture and hold the next rain event. So again, when you're looking at an active rainwater harvesting system, this is different than just a detention pond or retention pond where it's going to sit there and then slowly percolate into the ground. It's capturing it and then very quickly dealing with it in a responsible manner. These are two tiny homes, just to give an example of places that don't have a huge rooftop runoff. Both of these homes operate solely on harvested rainwater from their rooftops, and they're both only dealing with about 500 or 600 square feet of rooftop. So obviously their usage in the home is less than if it was a large home with a large family in it. But even with limited rooftop, there are families and homeowners enjoying life because they have water in their home supplied by rainwater harvesting. Both of these jobs used 3,000 gallons of stored water. I want to hit on these next two are for, this is a commercial agricultural application. And just to show that even in this job, the exact same 5-step method of rainwater harvesting is used. It's just scaled up to handle the 80,000 square feet of rooftop footprint with a 100,000 gallon storage bladder, but all of the components are the exact same. So you can see on the top right picture, mounted again on this post, this is a pre-filter. So the downspouts are running through the pre-filter before going down into the ground in this situation. The pipe's not in place in this picture, but those underground pipes, after they go through the pre-filter, would route around towards this big storage bladder that's capable of holding 100,000 gallons. Even in this tank, the biofilm grows and keeps the tank completely slime-free, color-free, and odor-free. So by the time it gets pumped out, it's clear. It just needs to go through those same steps I described earlier between a sediment filter, a carbon filter, and an ultraviolet lamp. And then it is used to water, in this situation, chickens in these poultry farms. And here's an application with for dormitories. And so these are below ground fiberglass tanks capturing all of the rooftop runoff from the dorms. Their primary motivation was, again, being able to deal with stormwater runoff, not having this big irresponsible volume of stormwater entering the storm drain system or flooding out the road. And so water is stored in these big tanks, and then this skid on the right hand side, it's much larger obviously than the small filtration panel in homes, but it is then pumping the water out of these tanks and servicing laundries and toilets inside of these dormitories. And that's how they're draining out those tanks so that they're always ready for the next rain event to come in and that be stored. So what I have tried to share here are really these 2 points, that there are many applications for rainwater harvesting systems for residential use. It is not grandma's old cistern on the farm anymore. There's a lot of technology that's been developed for rainwater harvesting systems, and they are a real true value when integrated into homes. And I wanted to really try to drive home that proper processes should be adhered to, because if you just take a downspout and run it into a tank, you're going to run into issues with water quality And you shouldn't have to deal with that when you're talking about rainwater harvesting, because again, it starts as a very high quality water. So with that, I will open it up for questions. You can see there at the bottom of this slide, I've got our website, and on there we have a blog section with quite a few articles addressing in detail some of the bigger concepts in rainwater harvesting or specific questions and FAQs. So please feel free to go there as well. And I would just open it up for any questions.
Yeah, great. Thanks, Daniel. We got plenty of questions coming in. I've got a couple questions myself. And before we get to those questions, I just want to make sure I run through a couple things here. So I want to make sure you can see my screen there, right?
Got it.
All right. Well, real quick, some of the things I promised we would quickly go over on this one is the water efficiency rating score. And in this regards, really what we want to talk about real briefly before we get to those questions is this idea that there are tools scattered everywhere and ideas scattered all over the world and all over the web on how we evaluate rainwater. But I think we're finally coming to a unified approach to being able to do this. So the water efficiency rating score is a third-party verified tool that's used to predict water use for new and existing properties. The program is codified in the city of Santa Fe. It's embedded in incentives in New Mexico Sustainability Tax Credit, the Santa Fe Residential Green Building Code. It's in compliance in Santa Barbara for their multifamily properties, as well as a portion of the Package Points Plus Vermont Energy Code compliance path, and it's used in the National Green Building Standard, Green Star certification, and it's going to be embedded into the EPA WaterSense 2.0. So the tool, like energy modeling, evaluates all water usage, both generation and production, in the case of what we're talking about here, for both residential hospitality projects, and includes one of the most robust and science-backed projections for rainwater capture prediction. And so you can go to our YouTube channel and review a little bit more about it if you want to, learn a little bit more about the specific program and everything it has to offer. But real quick, just honing in here again, when you start to put together all of the inputs Daniel talked about, roof size, where you're located in the world, or at least the US in this case, how much rainwater you think you need, how much water your project is planning to use, is there filtration in place on the site? All of those details are inputs here that you can work with your WERS rater or WERS associate on to input the data in here and get a sense for how much water you're going to need. And then what it does from there is you can see it breaks down predictions based on weather data that's constantly updated on how much water you're going to be able to get during January, February, March, April, May, June, the entire year. And so you can get a sense for planning appropriately for your project. And then that feeds into incorporating this in a full assessment based on your efficiency from your appliances to your outdoor water use. So you can learn a little bit more about that over at wers.us. And like I said, we have a session on our website too. But we hope people can start using this as another way to assess rainwater prediction and feel confident using rainwater. Now we also need to quickly talk about how this fits in with LEED. So in LEED now we have the water performance pathway. So just think of energy performance. Now we have water performance. Your clients can know how much water they're going to use. And there's points you can get and requirements you have to meet for water use. We're talking about homes here, but this also is on existing buildings and commercial and basically all of the LEED applications. So here's the different points you can get in the homes rating system under the total water use, all the way up to 12. It can be nearly a fifth of the points you need to certify by reducing water usage. And the way USGBC handles rainwater currently is they really have a sort of hands-off approach where you just need to show to them some verification that the formula that you're using makes sense. So the one Daniel mentioned earlier, that formula he put together, something you could definitely use. And this gets inputted into their spreadsheet, into the rainwater harvesting section as gallons peak per month. And so you can see here from the WRS database, you would grab something from like August, which you'd have to, it's kind of blurry there, but 3,000 gallons projected per month capture rate, and you'd put that right into the section to grab your lead score. And as Daniel mentioned, many projects just use this to stop stormwater, and so you do get points in LEED for halting stormwater. So this is a 2-for-1 in the LEED program, where you can pick up your water conservation points on the total water performance, and then also use your rainwater calculations under the rainwater management on sustainable sites to pick up credits. So that's it for LEED, and now we're going to get into questions. Real quick, make sure to take that survey that pops up. It'll also be sent to you an hour later, so take it to get your CEUs. For those of you watching this in the future, not right now, on demand, get that 80% passing rate on your quiz to pick up your Con Ed. To find that quiz on our YouTube channel, go ahead and click on the YouTube link at the bottom, and then from there, click under the description, show more on your left, and then on your right, you'll see some sort of link directing you somewhere to find the quiz, and you'll be able to access that quiz, take it, and pick up your Con Ed. And then before we get to those questions, a huge thanks to our board of directors, our volunteers, and our top tier sponsors, Mitsubishi Electric, Build Equinox, and Rheem, and all of our sponsors. Thanks to the support that they give us. So yeah, let's get into some of those questions. There are a lot here, so I don't know if we'll be able to get to them all. So let's talk about, gray water. And so the question here is, it sounds like, and I've thought about this too, is there a way to take gray water or pre-filtered gray water and mix it in with the rainwater? Or maybe the short answer is, hey, that's going to ruin that sort of natural bio film that you're generating there.
Yeah, that certainly at this point would be a no-fly zone for the way we do systems. I've never heard of in the industry anyone doing that. But I also am not terribly experienced on gray water systems themselves and the quality of water that would be output from a gray water system. So I wouldn't have a very definite answer on that, other than definitely we would not do it as a company, right, for risk of damaging that biofilm.
Okay. Do the above ground storage tanks have breathe valves? I don't know if that sounds familiar.
Yeah. Great question, and that's something I put in the breeze over section. But yeah, certainly storage system venting for above ground or below ground systems is very important, so that they don't collapse or swell up, and it also allows that inflow of water to not be restricted by a big pocket of air that can't get out of the tank.
Yeah, I this next question, I mean, I'm still trying to mentally handle this idea that you're saying our tanks have to be full of bacteria. It's it's still a little bit distressing, if you will. But this question here, kind of getting at, what does this look like? What is this? Does it look like green algae, or what's the look of it?
Yeah, totally. So when we installed the system on our personal shop, I was going out there every week and watching it. And so over about the first 3 months, obviously the tank started out perfectly clean, and eventually it's very dark, very, very dark brown growth. And it grew to about 1/8 of an inch. I've seen it thicker in tanks before, as the tanks are older. But yeah, it's very kind of slick right there on the bottom. It's not like a gray haze throughout the tank. All the water in the tank is crystal clear. It's just kind of a big brown layer on the bottom of the tank.
Kind of like what you see in a nice pond, right? I mean, a nice natural swimming pool, maybe.
Right.
Depending on where you're at, I guess. But so you talked a little bit about roofing types, and you did mention solar, but what if the water hitting the roof does have solar shingles? You mentioned some water loss coefficients. I mean, can you use rainwater that hits a solar shingle? Does it change anything, or how does that work?
Okay, so solar panels I can definitely speak to.
Yeah, panels, what I meant, yeah.
Okay, yeah, certainly No problem. It's a great surface, similar to like a metal roof, just because it's not porous, and so you're not getting a lot of evaporation coming off of that. So yeah, it works great. And in terms of any kind of like specific brands of maybe solar shingles that I'm unaware of, be something to look into. But certainly solar panels, we have many clients we capture off of solar panels.
You know, I was interested to hear your thoughts on the asphalt shingles. You know, we haven't looked at too much. We just know we had a presenter on last week who talked about his old historic over 100-year-old home where they had the asphalt shingles. They tested them before they put their rainwater system in, and they were putting off lead. I believe he said it was cadmium was the other nasty thing that was coming off of it. So just, you know, I guess, I mean, the specific question here from the attendee is, you know, how, especially on the formaldehyde one that you mentioned, how would anyone even know if there was an issue with their shingles? Do you have any suggested type of testing, or how does that work?
Okay, yeah, great question. And it's kind of a tough question because there are so many different, obviously, brands and models of asphalt shingles. And this is probably not going to be a terribly satisfying answer, but I'd be glad to field questions if there are like specific brands. But essentially what we've done, Brett, is for any given brand that we are applying a system on, pulling up the MSDS obviously on that specific shingle, and really there's others in our office for that technical question. I apologize, that would answer it better, but there's things they're looking for in terms of structure of the shingle. And then we obviously have a list at this point of shingles that we have installed on, and then done lots of water quality testing after the system's in place, see where it's at. And so we kind of at this point just have a safe list of these shingles totally work. And we obviously also have a blacklist, like I mentioned. Ones with formaldehyde are definitely not used.
Good, thank you. Let's talk a little bit about the conveyance system. One question is, what are the advantages and disadvantages of wet versus dry conveyance pipes?
Okay, so one advantage obviously of dry conveyance pipes is depending on where you're at in the country, there's no risk of a freeze situation if you have a column of water in a pipe. You know, in Knoxville, it never gets nearly as cold as obviously you start getting north of Mason-Dixon line, and then there's parts of the country it wouldn't matter at all, and that wouldn't really be a benefit. But certainly the freeze can be a downside of a wet conveyance system. And then also just depending on the velocity you can get the water to enter the pre-filter at. Sometimes with the dry conveyance system, if it's a real long run and it's raining on one end and forcing it through that pipe, it can slow it down, which can be a disadvantage to keeping that pre-filter cleaned off from leaves getting stuck on it and things like that.
So that helps me understand a little bit more. I saw that conveyance system looked really nice, I think, on one of your first photos, kind of running there under the above the deck maybe. And I was thinking, gosh, I'm up here in the Midwest in Michigan in the winter, I was thinking freezing pipes and everything. But you know, how often do you see, and is there extra costs to these conveyance systems being used as sort of nice architectural features? I think of like one extreme example in Seattle where there's I think a Living Building Challenge certified elementary school where they have what I guess you would call a conveyance system on the inside that you can actually see and hear the water running through when it rains from like a biophilic. And then they actually use that water to flush their toilets and all the other things. But how often do you see that? Is it higher cost to do that, or I mean, and not necessarily that, but just, you know, using it as like an architectural feature?
Okay, sure. Well, the majority of projects we work on, the goal is how well we can hide the conveyance.
Okay.
We have done a few projects on, we recently did one where it was a dry conveyance system, but it was the conveyance pipe was going over the top of a driveway, over towards the storage tank on the other side of the driveway. And so essentially, if you can picture kind of a big wooden arbor type situation was built over it, and then
Mhm.
the plastic conveyance pipe was set into a wooden channel, and it kind of was a cool little conveyance suspended system like that. Kind of looked like a pergola by the time it was all built, and he kind of built around it.
Right.
But truly, Brett, the majority of experience I have, I think it sounds really cool. Where you mentioned you can see through the clear pipes, but mostly the challenge is how can we not see the conveyance at all?
Right. Makes sense. Yeah, that makes sense. Um, Swimming pools, can they be used for storage? I assume you can use rainwater for swimming pools, but can they be used for storage?
Okay, in the methodology I'm showing here, no, because it's crucial to have the sealed storage system to maintain that
Mhm.
high quality. I
Mhm.
suppose if your goal was something where very low quality of water was required, you probably do that, but not for the system I've described.
Mhm. Here's a question that came in before we talked about the WERS. So hopefully that was helpful to the attendee. But do you have any other suggestions on calculators? Do you all provide a calculator for rainwater catchment online in any kind of formula way, or was that really just the math that you were sharing and people could take that?
Right. We personally do not. I know there are several. I know the American Rainwater Catchment Systems Association
Hmm.
at one point had one. We have obviously in-house basically spreadsheets that we've come up with, especially for different regions and looking at specific monthly rainfall data and plugging that in.
Mhm.
Um, but at this point, no. But I know there are several you can find online
Mhm.
that use that same basic calculation of this many gallons per square foot of hard surface.
Mhm. And how does the yield that you all calculate ultimately determine the tank size? And so, in other words, what's the yield versus demand relationship you mentioned?
Okay. When we look at a sole source rainwater system, the figure we use is this is going to be your only water supply. When your tanks are full, we want to look at your estimated demand and give you 6 weeks of
Mhm.
usage
Mhm.
without a drop of rain before your storage tank is emptied. So it's kind of a rule of thumb. We shoot for 6 weeks. And then certainly, you know, when you're talking about uh, different irrigation systems, it would be more of, well, how many cycles during what months of the year do you want to run irrigation? And then you just have to balloon the storage out to meet that.
Mhm.
It's very much case by case.
Right, right. Um, so, as far as water quality goes, what considerations are there for alkalinity?
Okay. Well, certainly for pH and on the alkaline scale or on the pH scale, rainwater would typically be naturally towards the acidic side.
Okay.
So we've had customers who, you know, as part of that filtration, we've got sediment, carbon, and UV. Um, it can go through like a calcite filter and pull it
Mhm.
up to being neutral, 7 pH. And so that would be the extent of the water chemistry on pH we would look at.
Um, Keeping on the idea of filtration, I think, yeah, we were talking with someone recently who kind of had a 10 micron, a 5, and then I think a 1. I see you're just recommending 5. Now, does that, do those recommendations maybe change on where the water is coming from and what can get into it? Or do you feel that, anything beyond the 5 is unnecessary and it should be able to do the job?
Okay, great question. Because the pre-filter is already bringing it down, depending on the pre-filter, to 150 microns before it gets in the tank, and then you're shooting for very
Mhm.
clear water in the tank. Our position is you could even go up from 5 and be
Okay.
safe. You know, many states, including the state we mostly work in, which is Tennessee, require before ultraviolet disinfection that any water, even if it's crystal clear purified water, go through at least 10 microns of sediment filtration before UV. And so we go to 5. That's kind of a standard thing we've brought over from being in the water treatment world. We just always did 5 micron in front of UV. But so the short answer to your question is no, using this system, we've yet to run into a case where dropping to a smaller micron is needed.
Okay. Is there a difference? Is there anything between 5 and 10, or is 10 kind of your next one up?
That would be usually the jump.
So also thinking about filtration, I think most people's minds, and I know my mind always goes straight to reverse osmosis. Mm-hmm. Is it necessary? Is it used in your projects maybe, or at the tap, or how does that work?
Okay. Yep. So that is, we still do water filtration, purification, mm-hmm. and a lot of reverse osmosis systems for municipal water, well water, and whatnot. For our rainwater customers, not necessary. Again, when we take a full analysis, send it off to the same labs that test for municipal water, and we're looking at 75 different things in the water. The quality of the rainwater is comparable to reverse osmosis, and just not necessary to have that extra purification.
Sure. Is there typically on the UV, I've heard some different thoughts that just a UV light in and of itself isn't good enough. It has to have a certain strength or time of water flow, or do you, I guess without getting way too far into the weeds, I mean, is that a true statement, or is any UV just fine?
No, yeah, that's an important statement, because there are a lot of ultraviolet systems that either come from other countries that have less strict regulations than the States, and so they do have a much lower UV light intensity, and so there are different scales, and there's commercial UV lights that would have more, but you're looking for 30,000 millijoules, and so there are systems that have less, and you'd want to avoid those. And then, yeah, certainly it needs to be a system that has flow restriction. So if your lamp is rated for 20 gallons per minute, it's important that there be restriction before going into that system at 20 gallons per minute, because you can't exceed that flow rate and get water through too quickly for the UV to do its work. And then the other risk with UV is always why there's the law on the sediment filter, is that if there's any sediment for the bacteria to piggyback behind and get past that UV light without coming into contact with the rays. And so if you're achieving crystal clear water at the appropriate flow rate with the correct intensity, there's really no disinfectant more powerful than UV, because it'll also take care of cysts. So things like chlorine cannot penetrate a shell of a cyst, and so UV does, and it's effective against that.
I didn't know that. Thank you. So energy efficiency on the pumps, do you all get into that a little bit, or are pumps kind of relatively the way they are? Are there Energy Star certified ones? How much do you kind of go down that direction and review the different pump types that you're using?
Okay. Not terribly far in terms of details, and I apologize, Brett, and whoever asked that question. When we're looking at a pump curve and saying, hey, this home needs this many GPM, a big part of calculating that is, well, how many feet are we having to pump out? And so I guess what I'm getting at is, when you're not pumping out several hundred feet out of the ground, you're just pumping right out of the tank, the curve becomes a lot more desirable, and you can use much smaller pumps to hit that flow rate target. I wouldn't have great answers though on Energy Star rating and things like that.
Sure, fair enough. Talking about tanks a little bit, I know you showed a photo of 3, I think, nice metal ones up, and then you said they filled kind of at the same time, and then one big one. Other than just personal preference on look, is there any reason you would pick one or the other?
For a residential application, it would be looks. Typically a steel tank comes with a longer manufacturer's warranty, but when you're talking about a quality thick polyethylene tank, they're extremely durable. So it typically would usually boil down to just aesthetics, personal preference.
And I guess I meant you showed 3 metal tanks, 3 steel, and then you showed one.
Okay.
Is there a reason you would go one or the other? Or?
Okay. Aesthetics again in those 2 examples.
Yeah.
There are cases though, especially if you're doing internal storage in a basement or whatnot, when you might need to go with smaller tanks to fit through an entryway and then chain them all together, where you couldn't just do one big one. Or if you're restricted underneath a porch and you've got support pillars and you've got to fit tanks in. So strategically, sometimes it makes sense to go to smaller ones, but often it's just for aesthetics.
So I was on a call last week about rainwater. It's just, we did not plan this, I promise you, just perfect timing, I guess. But and there was some concern about the basement tanks, especially in a cold weather climate where the cold water coming in would actually steal the heat from the house. Now, I know you're not really dealing with cold weather climates. Maybe you have the reverse problem down there. Have you heard of anything like that before?
I can't say I have, Brett. That makes sense. I can see that in regions of the country where that's a big consideration, but it's just not been something we've run into.
Right.
With that passive kind of thermal considerations. Yeah.
Any other concerns you could see other than I suspect general flooding of the house, putting the tanks inside in the basement?
Yeah, if we do that, we usually insist on having some floor drainage for an emergency situation.
Yeah.
But a lot of people are concerned, especially when the tanks get put in during a home build before the first floor comes in, so the tanks are kind of locked in. Of what if one gets damaged? I would just make the point that most tanks can be repaired. So even if worst case scenario, they got a big hole drilled through the side of it, the tanks can be repaired without having to pull them out and put them back in.
Right. Yeah, that makes sense. Well, that's a good question, and that kind of leads me to another question I was going to have. And it's kind of 2 in 1, but it's just looking at costs. And I know there's so many variables out there. So I'm certainly based on just where you're located versus code versus the pandemic itself seems to have caused home building costs to go nuts. So just generally speaking, though, the cost trade-off where you choose between drilling a well and going rainwater, can it be more financially lucrative to avoid drilling the well? And then I guess, would it be way cheaper to put it into a new home versus having to retrofit it in later? I mean, or would it not really make much of a difference? Can you be rainwater ready for the future if you wanted? I mean, just talk a little bit about some of these cost factors in the decision-making process.
Okay, very good. Well, hitting the integration during home build, yeah, a lot of the work that you often run into on a retrofit job, we're doing one right now where we're having to bore under 2 driveways and 4 concrete walkways to get conveyance pipes in. That, of course, if it was planned up during the build, the amount of work would have been a fraction just to get that conveyance system put in while everything's being dug up. That's a huge area where some planning up front, even if you think, well, someday I might want to do rainwater harvesting, to instead of using, cheapest corrugated tubing you can get to just get it out in the lawn, if you put in a quality infrastructure of a conveyance system, then usually a system can be applied a lot easier. And then certainly things like just coordinating where the filtration panel would go and making sure you have the electrician and plumber have the appropriate loop and power there would make you very rainwater ready. Outside of those things like having to bore under or undo a bunch of work to be able to get a tank in and whatnot, there's usually not a huge delta in price for retrofit versus new construction, depending on the site. In terms of well versus rainwater, we are working with a guy right now who has come to within 85% of being done with his home and decided, well, I got to get water on the property now, drill a well. Drilled a 1,000-foot well, dry. Drilled a second 1,000-foot well, completely dry. And so when you look at situations like that, yeah, one dry well is the cost or the very majority of a cost of integrating the rainwater system, and then you're looking at a second dry well. And then the other thing you got to consider on a well is any filtration equipment you might need. In East Tennessee, we got a lot of iron and sulfur wells, acidic wells, all sorts of problems. And so you've got the raw cost of drilling a well, which a lot of times is comparable to a rainwater system, sometimes even less. But then you've got all the ongoing maintenance and cost of water treatment equipment.
Yeah, that makes sense. Thank you for doing that. So here's a kind of a bigger question and leading to hopefully a smaller, easier answer if you don't know it, but if you've considered it, you know, and there's a lot of people concerned just about having enough, you know, in these questions, I see a lot of concern about just having enough rainwater in general. And I think about, you know, we work with a lot of folks or get involved or read about a lot of what we call sort of climate resiliency planning. So we start to assume that certain areas are going to get wetter or drier, you know, over the course of time. And so just we ask then, okay, what can we do now when we're renovating or building new to prepare to, you know, for that? In the case where, you know, like the area I'm in, we know we're going to get more rainwater at a certain time and less in the summertime. We already see that happening right now. So if you were to find an area where you might have, I mean, do you look into planning really far ahead for your clients? Like, oh, well, maybe there's this area that we're going in, it looks like we're predicting droughts, you know? So you probably want to, you know, size your roof more, size your tanks more, or can you daisy chain it or add on more later? Is it expandable? So that you could just easily put it in, whether it's in a basement or dig up the ground, add it in real quick without a lot of work. How does that work?
Okay, yeah, great question. Our approach is this, Brett. We look at historic data for a region, obviously. NOAA has got a lot of good data at different places, and we base the system off of that and the storage, knowing that to affect the only two real factors of how much water I'm going to have, your yield potential, which is your roof, and your storage volume, knowing both of those can be, as you said, increased. So if you had to add another storage tank, if rainfall data shifted dramatically with the climate, more storage could be added, or, you know, an additional garage or carport, something else could be added to get more yield as well. But the short answer would be we just look at historic data. And in our region of the country, and I would imagine, depending on where people are coming from, you know, I'm coming from 55 inches is about a good average rainfall in the course of a year, up to 70 if we get over into the Carolinas where we do a lot of work. So it's not as big of a concern of, am I going to have enough rainwater volume as a lot of places.
Do you see for the stormwater kind of reduction, do you usually see that from because it's a code requirement, or do you ever install them for, like you showed that picture of the dorms where there's like an incentive, you know, that could be given for the project, or maybe it's both?
Yeah. So for the dorms, it was credits for their stormwater system that was going to be hugely expensive if they were just putting it into the sewage system. And so being able to have that system, they're saving all of that. Usually it would be for hitting a certain stormwater compliance for either a town or a county where they're putting in a bunch of hard surface and need somewhere to put it. Then rainwater would be brought in just to meet that compliance. And then residentially, it would typically be for cases of neighborly dispute. You don't want to flood out your neighbor's backyard or their garden, building a new house, and then rainwater comes in and kind of assimilates that water. Typically not in the context of any kind of a code, just neighbors want to be decent.
Great, yeah. What about monitoring water use? So obviously, if you're on the city, you get a water bill, right? You can see how much water you're using. You can get a sense for it if you're trying to reduce water. You know, there you go. But once you go to well, you know, that's typically a lot of effort if it even can be done. So what about with rainwater?
Okay. Yeah. So in terms of tank volume monitoring. There's several ways to monitor what's currently in your tank, obviously, but total volume, a flow meter, if you were really curious on the outlet from the pump on the tank, would be the easiest way to know how many gallons have I used out of my system, obviously. Or, you know, if you want to know your total that's landed on your roof, it would just be looking at last year's rainfall data, your roof size, and you'd have the exact amount of rain that went through your total system. And then from there, you could infer how much was overflow based on how much you actually pumped out of the tanks.
What kind of opportunities or challenges have you run into on what we call the home valuations side? So whether it be, you know, appraisers and lenders either not understanding how these work and properly valuing them, not being able to give enough funds to the team, you know, for the mortgage to pay for it because they don't understand how to value it, or the reverse. Oh, hey, this has a rainwater system. It's clean. It's way better than what's locally available. So therefore, your home is more valuable. What are you seeing there? Do you get involved in that at all?
Not as much, Brett. I don't get involved in that too much. Another great question, and I know I'm saying, well, I gotta get a good answer on that, but we've certainly not run into any problems, I guess I would say, because I certainly would hear of those of people saying, hey, I'm having trouble selling the house. We've had many clients who've obviously installed the system, sold the house. It's the sole water source for the home, and then the new clients pick it up and they keep using it and it works great. So I guess that would be about the extent of my experience on that.
So you obviously, you briefly talked about the farm, you talked about the dormitories. I mean, those really are getting into commercial aspects. I mean, what's really the difference though, you know, between commercial and residential other than just scale?
Sure. One of the big things is when you're talking about a commercial or an industrial property, usually the volume of water you can collect off of a huge roof and then the amount of water they're using every year means a real ROI can be achieved much quicker. You know, that farm, for instance, they were spending over $20,000 a year on their water. The first year the system was installed, their municipal water bill was $600. And so that would be one of the big differences. We can get ROI is a bigger motivator for commercial, whereas water availability, water quality, stewardship, responsibility is the bigger motivators for residential, because people usually are not spending tremendous amounts of monthly on their water bill.
Right. Going back to the tanks for a second, you know, at first I was seeing the idea of wood tanks, and I know that you did that in the old days, and thinking, you know, that sounds pretty bad, but then thinking, well, you want bacteria, I guess then it makes sense. So what if, I mean, is there any initial trade-off? You had mentioned you could do pure wood or you could line it with polypropylene, but, you know, let's say someone's trying to avoid plastic. You know, we're getting more folks trying to get away from plastic. I mean, what is really why would you line it with that versus not doing it? And then could you line it with metal instead?
Okay. Yeah, certainly. I mean, if it were lined, if it were basically like a stainless steel tank inside of a wood cladding, that would work just fine. And people clad polyethylene tanks all the time to make it look like a timber tank.
Right.
So if you're dealing with a lined tank, typically you're looking at a different price point because you're not relying on a sealed wood panel connection. It's more aesthetic. And so that would be a big reason for a liner. In terms of water quality, things like that, that's really not a huge factor. So it really would be, as far as our experience with it, a personal preference. If people say, I want to avoid a liner, I'd really go fully timber. That's kind of just their personal preference.
And that costs more to do that, you're thinking, than just from the design of that tank?
Right.
Yeah. Have you ever heard of bio-based liners?
I have not.
Not heard of it. No, that's fine. And I was trying to see if there was another question here, but I think we've gotten through quite a bit of them. There's a lot of very, let's see. There's another here. If there's a timber without liner, does it need to stay wet still? I don't know if does that make sense?
Yeah, for the wood to be moist enough to make that seal. Yeah, I mean, there'd always be a certain volume of water in the tank for the biofilm. And so, yeah, depending on the volume of the tank and how much would be dry outside of just what you keep on the bottom, that would be a consideration, depending on where you're at in the country, obviously, and how much rainfall you're getting, how consistent. If it's sitting for a month at a time, totally dry, then yeah, you're going to run into issues.
Yeah. A couple more questions. You still have time for a couple more questions?
Yeah, sure.
Yeah, great. So I guess, just talking a little bit about usage, I guess comparing it mostly to city water, are you seeing or having any of your clients report any kind of return on investment at any point, or do you help them calculate that at all?
Okay. Yeah, I mean, from municipal, it's really not usually coming into play very soon. When you're talking about comparison in a well and the investment of a well versus investment in rainwater, that's a very easy conversation to have. But for municipal water, depending on your water company, they may require a meter on the rainwater anyways for your sewage. And so you still end up with that kind of a bill. So if you're looking at it in terms of ROI, usually you're not seeing one very, very soon. There's got to be other motivators for doing a system.
Sure. And that's including even if you incorporate the stormwater into?
Well, no, that would change the equation if you're on a site that would require some other stormwater pond or whatnot. Then certainly, if you're looking, well, I got the cost of the rainwater, at least I'm recovering some monthly.
Right.
But if you're just talking strictly water bill, you pay your utility company versus rainwater system replacing that.
Right.
That's usually where you don't see it. But if you're replacing the need for some other stormwater control, certainly. And then even there are areas of the country, like I mentioned, that farm, they're paying over $10 per 1,000 gallons of municipal water. So that's pretty high compared to a lot of the country. And so where, as I mentioned earlier, kind of future ROI, where water bills will go, that conversation could change quite a bit, but as of today.
Right. And what kind of materials are typically used in the conveyance as far as the piping goes? Are different kinds, or one you like to use?
Okay, yeah. So SDR 35 it's a drainage pipe, smooth wall, and then certainly if you're going under driveways and things like that, using a Schedule 40 thicker wall weight bearing pipe you got to make that conversion.
Okay, great. Well, hey, there are probably definitely some more questions here, but I really want to encourage everyone to reach out to you directly on some of these specific ones. So my last one to you before we send you off is, I guess, where can people find more information if they want to learn more? Are there any of those case studies you went over available on your website? Where can people reach out to contact you?
Okay, yeah, definitely. Thank you. Our website is the number 4 perfectwater.com. And if you go there, you'll see the tab for rainwater harvesting, and you can go down that trail, and we've got all the blogs we mentioned, and yeah, certainly case studies, and try to make it useful information so you could go there.
Great.
Then, yeah, our office number is obviously on the website too. So if you wish to reach out and talk more, you could reach me there.
Yeah. Well, Daniel, we thank you so much, and huge thanks to your associate there, Ezekiel, who did a lot of the back-end work setting this up with me for a long time. We've been working on it. So thanks to you all. Thanks to Perfect Water. Really appreciate all the great work that you do and sharing this with us here. And everyone else, we want to just wish you well. Stay safe out there. And hopefully we can beat this thing and see you all in person someday soon. So Take care, everyone. Have a great rest of your week. Goodbye.
Thank you, Brett. Bye.